This is the Lewis dot of ionic bonds video. By the end of this video, you should be able to write the Lewis dot diagram for an ionic bond. Materials you need includes a pencil and the Lewis dot of ionic bonds video sheet, which we do the next day you have class. Ionic bonds are made up of a positive metal cation and a non-metal anion. Remember, cations have a positive charge, anions have a negative charge. You might have a polyatomic ion in the place of one or both of these ions. The definition for an ionic bond, this here's our definition, is an electrostatic attraction between oppositely charged ions. So after we've made the positive ion and after we've made the negative ion, the two are going to come together and form the bond. Now you may have heard in previous science classes that ionic bonds are caused by a transfer of electrons. That is still a true statement. It is by transferring the electrons from the positive to the negative ion that you form the ions, that they have two different charges and that they're able to attract each other. Okay, doing the Lewis dot of ionic bonds. We have our example here, sodium chloride, the metal and the nonmetal. You want to start by figuring out what the valence electrons are going to be. Now, sodium is right here, and chlorine is over here. Sodium has one valence electron. I'm going to represent his one valence electron by an X. Chlorine has 7 valence electrons, and as you can remember from the past, the first two are in the s orbital, they go together. Then the p's are going to spread out before they pair up, and then I end up with 7. I'm going to go ahead and get rid of my periodic table now, because I will not need it for the rest of this particular problem. Now we know from the past that metals want to lose electrons to form their stable octet. This one's going to lose 1 electron. Chlorine and nonmetals want to gain electrons in order to form a stable octet. This one is going to gain 1 electron. And what happens is the following. This electron here is going to leave sodium and be transferred to the chlorine. So what you end up with is the following. The sodium, which has now lost his valence electron and is an ion. So we're going to put brackets around him, and since he lost 1, he has a 1 plus charge. Chlorine has gained 1 electron, so he has the 7 he had originally, plus he has this electron that got transferred. So we can see here where that extra electron came from. He now has a negative charge. Together, this is an ionic bond. And you want to put them close together. So we're going to show them close together. Sodium ion and the chlorine ion close together. We're going to put in their charges. And we're going to put in the electrons. And then we are done. Let's try another one. Lithium oxide. Lithium right here has 1 valence electron. So Li and 1 valence electron. Oxygen over here has 6 valence electrons. Remember the first two to go together, they're the s electrons. Then we're going to spread out the p's before we pair them up. Now lithium, like all metals, is going to want to lose his electron. So this one is going to lose his electron to the oxygen, which now gives this lithium his a +1 charge. And makes him happy because he now has his stable octet. However, oxygen still has this missing spot. We're going to fill that up by having another lithium atom, which is going to transfer his electron to that last missing spot. When we do, oxygen now is going to have his original 6 electrons plus the 2 that he gained from the 2 different lithium atoms, giving him a 2 minus charge. Oops, it's a plus. And the lithium has lost his 1, so he is a +1 charge. Now a few things to notice. First, the positive ions now have no shown electrons in this Lewis-Dot structure. The negative ion, the nonmetal, has a full 8 octet. 1, 2, 3, 4, 5, 6, 7, 8. Also, we want to put the positive, then the negative, then the positive. We want to alternate the charges. It would not be correct if we did something along the line of this, because then you are showing two positives attracting each other. You just want to make sure that you alternate it so the positive and negative charges go in this order, and they alternate, and then you don't have two positives or two negatives side by side.